Yeah. Let's see this thing. Anyone got the answer for this? Vihan, you got it right. Others? Let's see. How many of you got the answer? Ishana, yeah, you got it right, Ishana. Vihan got it. Anyone else got the answer for this? Did you guys try? Forgot it exists. Most of you forgot it exists, no? You did remember. Okay, let's start off. So the idea is a straightforward thing. You have to consider disks. So at a point here, x comma y, consider a thin disk. Whose width is dy. So what you got is a disk like this, whose width is dy, and whose x coordinate is the radius. Agreed? Because if this coordinate is x comma y, that means this height is y and this distance is x, isn't it? Okay. So what is the volume of this thing? So the small volume of this thing is like a small cylinder, pi x square into dy. And it is given, what is this equation? Y is equal to hx square by r square. That means if you consider this point here, this point is nothing but r comma h. The total height of the cylinder is h. So from here we get x square is equal to y r square by h. Substitute here. Pi y r square by h dy. So the volume of this paraboloid will be integral pi r square by h y dy. So y ka value goes from 0 to height. So this is pi r square h. That would be y square by 2. Limits from 0 to h. You get pi r square h by 2. You get a pretty interesting answer. So there's a very good way to remember. And if you actually think about it, the question was no different. You know, you have done this similar one here. In this question, look at this thing. Huh? You took the same cylinder. You took the same volume. Everything was same till here, right? The only difference is here x square is r square minus y square. You substituted here. That was the only difference. And here x square is something else, y r square by h. Other than that, everything else is exactly the same. So there is a very good way to remember this answer. If you consider a cylinder of height h and radius r, and if you can keep a paraboloid inside it, if it's enclosed by a paraboloid like this, so the volume of the paraboloid is half of the volume of the cylinder it encloses. That's an easy way to remember. Half of volume of the cylinder, which encloses the paraboloid. So if you can keep that paraboloid inside a cylinder of height h and radius r, उसका half volume होगा. Which is half into pi r square h. Please have a look at the integration. See why you didn't get this. All clear with this? Anyone not clear with this? Arnav, Arya, Abhinav, clear with this? Daksh, Surya, Purvaja, Nikhil, Devansh, Ojas, clear? That means if you think about it, this guy which is there, if this is the paraboloid, that means the remaining area which is there, both are equal, isn't it? So the area, the volume of the red and the green shaded things are equal. Means that empty space is also half of the cylinder then. Volume of the red and the green shaded volumes are equal.
Sir,
Hmm.
sir, is it possible to create multiple paraboloids with the same enclosing cylinder but different curves? Like here, the curve was given. So can we have a
It doesn't
different curve?
matter. It doesn't matter. If you try to make it curve, means what you're trying to make it more sharp. If you try to make it more sharp, the cylinder also becomes small, na?
No, sir, like the curve somehow a little more straighter or more curvy.
Then it is not called a paraboloid.
Oh, okay.
Then you won't get this x square function. You'll get some other thing.
Okay, sir. Okay.
Clear?
Yes, sir.
Yeah. Next one. Let's say we have a sheet like this. This is your x-axis. This is your origin. The upper and bottom are symmetrical. So the equation of this upper curve, this is y is equal to 2x square. And this coordinate is 2, 0. Find the area of the sheet. Hope everyone has given the exam yesterday. Did you find any errors or anything? You found any errors? How many questions you found? Did someone send me that? Purvaja, you found any errors with the questions?
Sir, for one of the questions, I think the option wasn't there.
Okay. मुझे photograph भेज देना बाद में.
Yes, sir.
Sir, even I had sent you one photo.
मैं देखता हूँ, चेक करता हूँ. एक बार सिर्फ टैग कर लेना क्लास के बाद.
You said you replied. You said you will see.
I must have forgotten again. So just tag me again. I would see now, but let's see. Between your message and now, there must be hundreds of messages in the middle. So just
Okay,
tag me
I
again. I'll
will.
check it out.
Yes.
Yeah. Problem क्या है ना? I can't change the error before the exam gets over. It should be same for everyone, na? If I change it in the middle, then for some other person will see some other question. I have to keep that error till the exam gets over. So let me check it today. How do we do this thing? Find the area of this sheet. (32 by 3). We have one answer. Anyone else got that? (16 by 3). Ansh, you're forgetting there is an area upper and bottom na, so double karna padega. If you remember, this was the whole basis of integration that we started with. So let's do one thing. Let this area be A on the top part, and let this also be area A on the top part. So at a distance x from the origin, take a thin slice dx. This is how we started the whole thing actually. So what you got is a thin rectangle. So this height is y. Basically, this coordinate is x comma y. So at a distance x, the height was y. So this is y and the width was dx. So the area of this thin rectangle, let's call it dA, which is length into breadth. But it is given y is nothing but 2x square. So the area A would be integral dA, and remember this thing is going till 2, 0. Isn't that how we started the whole integration ka story actually? Consider a small step and then finish it off. This is how we started the whole game. So integral to x square dx from 0 to 2. That would be 2x cubed by 3 from 0 to 2. That would be 16 by 3. This is only the upper strip. So area of the sheet will be 2a, the top and the bottom. I just calculated only the top part. 32 by 3. Or if you wanted the full sheet, now you could have done like this actually. This is also y at the bottom. So this will be 2y then. You should have taken 2y into dx if you wanted the whole sheet in one go. That also would have worked. Do check out your answers. Yeah, Vignajit, Pratik, Shana, and Vihan all got it. Any doubts on this? So if you see, these are one type of questions that we have handled last time, areas and volumes. Everyone make sure your cams are, your faces are completely visible on the screen. Prashank, do adjust your cam. Clear? Niharika, Taksha, got this? Ahana, clear? Abhinav, Adi? The next one. Integration of a vector. So if you give me a vector a bar, which is ax I cap, ay j cap, az k cap, and if I have to integrate this a bar dt, straightforward, just like differentiation, you will just integrate each part separately, ax dt I cap, ay dt j cap, az dt k cap. Example. Let's say if I take a is equal to t square I cap plus t j cap plus t cube k cap. So integral a bar dt, let's say from 0 to 1, I give you the limits also. This would be t square dt 0 to 1. So the I cap, j cap, k cap will simply be just outside. T dt 0 to 1. This would be t cube dt 0 to 1. Then basic integration, t square dt is t cube by 3, limits 0 to 1. So all the integration will be as usual. There's nothing new as such. It's brute force, just standard formulas. So this would be 1 by 3 I cap, 1 by 2 j cap, and 1 by 4 k cap. Have a look at this. Do check this out. Clear? Let's see. Next thing. Now, now we are slowly entering into the kinematics part. A relation between position, velocity, and acceleration. We have done this in integration, differentiation, same thing. So we know velocity v bar is dr by dt. So we can write integral dr bar is integral vtt bar. So we can start integrating. Now it's a reverse thing. We know acceleration is dv by dt. So we can write integral dv bar is integral a bar dt. We also know acceleration can be written as v dv by dr, which is a bar dr is integral v dv. Getting it? This is a vector form. So in one dimension, we will simply write v is equal to dx by dt. Then this would be integral dx. Basically, I cap, j cap won't be there. So if you ask me, this is a more superior form of writing. But in this, you can have I cap, j cap, k caps. If you just have a single dimension, you will see both the varieties. So you have to do this thing. So a is dv by dt. So dv is a dt. I'll show you how to put limits and all that stuff. v dv by dx. So the idea is this thing. See, if someone asks you, they give you the position vector and they ask you velocity and they ask you acceleration. What should you do? You should differentiate, isn't it? You should know just this order. In the ladder, where are you? What is given, what is being asked? So if you want velocity, differentiate. If you want acceleration, again differentiate. But if you're going in the reverse direction, someone gives you acceleration and they ask you velocity and they ask you position vector. This time we integrate. So this have an idea, where are you? What is given, what is being asked? If I give you a bar and ask b bar, you have to integrate. If I give you v bar and ask a bar, you have to differentiate. This much idea you should know. And be careful, both the formulas are different. Do have a look at this page. No need to write down, have a look at this. I hope you already have an idea about this thing. So Now, let me take an example. The examiner, they would give you something like this. Acceleration of the body is given by A is equal to T. T is time. Meaning when time is 0, there is no acceleration. As time is increasing, you're accelerating much faster. Find velocity and position as function of time t. And now, initial data is important. Initial velocity, the symbol is u, is 2 meter per second. Initial position, x is equal to 3 meter. So let me show you how to do one problem. So acceleration is given. So this is how we start. A is equal to t. So you want to find velocity as function of time t. Now see, A has two forms, right? dv by dt or v dv by dr. When to use which one? In the question, you can clearly see everything is being asked in terms of time. Then use dv by dt. If everything is asked in terms of position, then use v dv by dx. So A is dv by dt. Send dt that side. T dt. Now integrate on both sides. Now when you integrate this, dv integral t dt. Now understand the meaning of limits. Initial velocity, meaning time is 0. So when time t is 0, the velocity u is equal to 2 meters per second. After some time t, let the velocity be v. So that is the meaning of that limits. So after time t, let velocity be v. I hope you're getting the meaning of lower limits and upper limits. Lower limits meaning your initial condition. At t0, what is your velocity? After time t, what is your velocity? Then integration v, this will go from 2 to v. This is t square by 2, limits will go from 0 to t. So this would be v minus 2 is equal to t square by 2. So we get velocity is equal to t square by 2 plus 2. This is your velocity as function of time t. This is how they'll frame questions. They'll never ask you integrations directly. Next, you want to find position. Now, what is velocity? So v is t square by 2 plus 2. Velocity is dx by dt, which is t square by 2 plus 2. So we have dx is equal to t square dt by 2 plus 2 dt. Again, integrate. So double integration basically. Half comes out, integral. If you see, I know it looks a little big and all, but if you see it is just brute force. Everything is exponent integration. There's nothing new you're doing as such. Again, when t is 0, your x is 3. So do understand, don't put always 0 to 1, 0 to this thing. At t0, x ka initial value is 3. That is the meaning of this whole thing. When time is t, the position is x. So this would be x, limits will go from 3 to x. This guy would be t cube by, there's already 2 there, so 3 into 2 will be 6. This is 2t, 0 to t. So that your final answer would be x minus 3 is equal to t cube by 6 plus 2t. Check. This is how you handle a problem. Are you getting how I did this? Let me show you one more. But please have a look at this step by step. Any step that you're not convinced, please ask me.
Sir,
Vihan.
so the initial result we get when we integrated v or r, we were getting actually change in v and change in r.
Meaning if you have just taken this whole thing, there's a change.
Okay, sir. So that's what we're getting here, and then we just converted into
We are
equation
doing
with the-
changes final minus initial. ना initial को set shift कर रहे हैं.
Okay, sir.
Think about it. When you integrate dv, what you'll get is actually v final minus v initial, isn't it?
Yes.
That is always
Yes,
the change.
Okay, sir. Yes.
Everyone got the steps? Arya, clear with this? This was something similar, no? What you're asking? Something similar. Let's see one more example. Acceleration of the body is a, which is constant. So a is given constant. Initial velocity is u. And let's say initial position is x naught. Initial meaning t0. Okay. Now we need to find the velocity and position. Now see. So a is constant. So a is dv by dt. So dv is a dt. So integrate on both sides. We'll stop writing this later on. So this will be integral dv. Now see, a is a constant, so it comes out of the integral. Are you getting the difference between this and the previous one? In the previous case, a is equal to t, right? This part. I couldn't take it out of the integral. It has to be inside. But because now a is constant, it comes out of the integral. Limits will go from 0 to t, and initial velocity is u, final velocity is v. So this will be v, limits u to v. This is a, limits 0 to t. So we get v minus u is equal to at, or v is equal to u plus at. Ever seen this equation? This is your kinematics ka first equation. V is equal to u plus at. How do you think it was derived? Now, once you got v is equal to u plus at, what is v? Dx by dt. Send dt that side. U dt plus at dt. Integrate on both sides. This would be initial position x naught. This would be x final. This would be u is constant again, u to t. Plus this is a is constant again, at dt 0 to t. This would be x, limits will go from x naught to x. This is ut, limits will go from 0 to t. Plus a t square by 2, limits will go from 0 to t. So this value would be x minus x naught is equal to ut plus half at square. And you know, x minus x naught is nothing but displacement. This whole term here, the change in position is nothing but displacement s. So this equation becomes s is equal to ut plus half at square. This was your second equation. So these things can be derived with integration. And if you also look at this, there's a second form, a is equal to v dv by dx. So this will be v dv is equal to a dx. Integrate on both sides. This will go from u to v. This will go from x naught to x. This is v square by 2. Limits will go from u to v. This is ax. Limits will go from x naught to x. So we get v square minus u square is 2ax minus x naught, which is v square minus u square is 2as. That's your third equation. These are the three uniform acceleration ka kinematics equations. So be careful. Why do we integrate v instead of v minus v? Because u is a constant, right, Vihan?
Okay, sir.
U is that initial velocity, ना वो constant है, उसको क्या integrate करना है? See ना, we did integrate here, but u came out of the integral.
Okay, so like we want to integrate v such that it is a function that gives us for
V is a
any
variable,
time
na?
t.
Yeah.
Okay, sir.
Please have a look at the steps. So these three formulas which we are using till now were actually valid only for a when it is constant. If a is changing with time, for example, देखो ये question जैसा, if a is changing, There is no other way but to do this integration, double integration. You have to do this process. So keep this in mind. If A is constant, your life is easy. Directly use the formulas, get the answers. If A is changing, you have no other option but to integrate. That's why first I showed you the integration. Then I'm showing you a constant. Do have a look at the integration. Ask me if you're confused, like any step that you're not convinced. Next one. Clear enough? So now you guys give it a try. I hope everyone got a basic idea, like how the integration goes. So let's see a few problems. You'll get the better grasp of it. But let me write a statement before that. So these three equations which we derived, v is equal to u plus at, and s is equal to ut plus half at square, and v square minus u square is 2s. These things are valid only if a is constant. So don't use them if a is changing. If a is changing, you don't have an option but to integrate. If a is variable, you have to integrate. A dv by dt, v dv by dr, and v is equal to dr by dt. Most people do that mistake. I have seen. You know what they do to the mistake now? A is equal to t. They ask you find the velocity at time t. You know what they do? V is equal to u plus at. A is equal to t. They'll substitute here and they'll write u plus t square. You're getting the mistake? People did that. People do this kind of things. And that will be there in the option hopelessly. So you can't do that. If a is equal to t, first of all, this equation is not valid. You can't substitute a is equal to t. You have to integrate. Itna kyun? Observe karke dekho. U plus t square. Actually, what was the result? It is t square plus 2 by 8 plus 2. Isn't it? It was something else. You just can't directly add it up. So keep this in mind. We'll be wrapping up the chapter today. So next class, when we start with kinematics, so you'll encounter all these things. That's what I was saying. Every chapter that we do, they'll keep adding up for the next chapter. So if you see here, we are doing what vectors also coming in this. Calculus is there. So kinematics में vectors, calculus, kinematics will come. NLM you'll get everything. So when we do the 15th chapter, all 14 chapters will come. That's the best part. Copied? Clear with this thing? No need to copy, but got the idea, right? So you guys try this. Acceleration is t square plus 2. T is time. The initial velocity u is minus 2 meters per second. Initial position x is equal to plus 3 meters. Find v of t and x of t. I hope you remember what is v of t and x of t is. F of x, y of x meaning function of x. Remember? So if instead of writing every time find the velocity as function of time t, find position as function of time t, yeah, just put x of t. So when you see the symbol, don't get scared. What this means is position as function of time t or position at time t. So in some questions, you will see this thing v of t. So don't think what the hell is this. Let's try. Exact same thing as an example, I just change the numbers. Try, everyone. I'll give you a minute more. Let's get the velocity part first. We have one answer. Yeah, right, Vojas. We have one answer. Others got an answer, type in the chat box. Okay, answer directly went to X. Yeah, Ansh, you got it right. Yeah, Vihan, Arya got it. Surya, you goofed up, right? Surya there. Check it out. Meaning you're almost divided by 3, yeah? You just messed up one sign there. Check it out. Ishana, you're right. Vihan, you're right. Devansh, you're right. Ahana, right. Yeah, I think most of you did get it. Yeah, most of you did get it, the first part. So, acceleration is t square plus 2. This is dv by dt is t square plus 2. So, dv dt plus 2 dt. Integrate on both sides. Now, initial position, this is minus 2. This is t, this is t, and this is t. Yeah. So you can integrate this thing. So that will be v. Limits will go from, sorry, this is v. V minus 2. This would be t cubed by 3, 0 to t, plus 2t, 0 to t. So put the limits v minus of minus 2 this is, isn't it? V minus u, na? U is minus 2. T cubed by 3 plus 2t. So we have t is equal to t cubed by 3 plus 2t and minus 2. Check. That's your answer. Once you got this is again dx by dt. Integrate this again. Be careful here, the limits would be 3 to x. This would be t power 4 and 4 and 3 is 12 in the denominator. T square by 2, that 2 and this 2 will cancel. So you end up with x minus 3 is equal to t power 4 by 12 plus t square minus 2t. Check. Yeah, most of you did get this thing right. Easy? I hope everyone is getting this. Brute force integration, there is nothing, think actually. Just put there and keep integrating, Let's see one more. Any doubts on this? Anyone not convinced with this, please ask. Clear, na? Adi? Got this? Ahna? Devansh? Clear? Arya? Clear with this? Niharika? Perfect. Next one. Acceleration of the body is a is equal to minus 3x. X is position. Now at x is equal to 1, v is equal to 3 meters per second. Every time they won't give you initial velocities. I can give you velocity at any position. Find velocity as function of x. Let's get this. Try. Give it a try. Just get some water and come. Okay, we have a lot of answers. Root of 12 minus 3x squared. Hana, you got it right. Daksha, you got it right. Bihan, you goofed up. Ishana, you goofed up. Purvaja, you goofed up. Devansh, you got it right. Let's see. I think you guys goofed up the limits, I guess. The first mistake. Did you take dv by dt? That's a blunder. A is in terms of this thing. So A is v dv by dx. Okay. So that is, how do you know that? You see now, A is depending on what? Here A is depending on x. So then use v dv by dx. If you take A is equal to dv by dt, fine, nothing wrong, minus 3x. Then you'll have dv minus 3x dt. I don't know how to integrate x dt, isn't it? Integral t dt is t square by 2. But integral x into dt, I don't know what is this. I hope you're getting it. There is no integration called x dt. So this is minus 3x. So v dv minus 3x dx. Integrate on both sides. This limits will be when x is equal to 1, v is equal to 3. When x is equal to x, v is equal to v. So this is v square by 2, limits from 3 to v, minus 3, x square by 2, limits are from 1 to x. So substitute, this will be v square minus 9, that is 3 square, by 2 is equal to minus 3 by 2, x square minus 1. 2 will cancel. We get minus 3x square plus 3 plus 9. So v is equal to root over 12 minus 3x square. Right? See, where did you guys goof up? Easy? Got the steps? Prashant, clear now? Be there. What happened? You got disconnected from the internet issue or something?
My screen got hanged, so I was waiting to. That's why.
Okay.
I saw that I was left. That's why.
Easy, everyone? Any doubts on this? See where it went wrong, everyone. The next one. Can I go ahead? Devansh? Arya, clear na? Great. So acceleration of a body is given by A is equal to minus kV. K is some constant. V is velocity. The initial velocity is u. Find velocity at time t. How do we do this? See, A is equal to minus kV. Now, how should I use dv by dt or vdv by dx? How do I know? Look at the question. Find velocity at time t. So you want everything in terms of time. So use A as dv by dt. So bring that v down. This would be minus k dt. Integrate on both sides. Time t, 0. This is u, this is v. Hope you remember this integration. Dx by ax plus b ka integral is 1 by a ln ax plus b. If a is equal to 1 and b is equal to 0, this will be simply dx by x, which is ln x. So this integration would be ln v. Limits will go from u to v. This is minus kt. Limits will go from 0 to t. So this is ln v minus ln u. I hope everyone was taught logarithms. Everyone has an idea, right? So in case you're not done, for now it is fine. If you got till here, it is fine. Let them teach you logs, you will get the idea about it. Ln a minus ln b is ln a by b. So this guy becomes ln v by u is minus kt. And there's a second thing. This is the basic introduction about lns. Ln a to the base b is c. Then a is nothing but b to the power of c. That is actually how we started the whole ln ka story starts like that. That b is the coefficient, this thing, and c is the power and a is the value. So here ln is nothing but to the base e, that is. So v by u becomes e power minus kt. If someone uses log, that is base 10. If someone uses ln, means it is a base e. Anyone has no idea about, anyone here who doesn't know anything about logs? Oh, just one. Okay. You can just check it out. YouTube में देख लेना 10 मिनट का वीडियो मिल जाएगा logs का. But Max में you have a full chapter, they'll teach you. ठीक है? But are you clear till this part? Then it is fine. You understood. So don't worry about it, because these kind of integrations will not encounter at least till September around. So you have time. Before that, they should finish it off. So v is equal to u into e power minus kt. Please check. That's your answer. This is a little different integration than what you're doing till now. X power n nahi hai. This is an long term integration. And this thing just keeps coming like anything, meaning, like I said, this keeps on coming a lot later on. And you'll have more dangerous integrations than this. There, can you see? D omega by omega. This is all a constant, ignore that. So this is dt. You can see this thing. It kind of looks like that only. Ln omega by omega naught. Look at the answer. This is how we will actually use integrations later on. All clear with this? Next one. Can I go ahead? If you got till this part, I think you did fine. Don't worry about the remaining if you don't know anything about logs. Next one. So till now, what we did was all one-dimensional, meaning there was no vector or anything. Now, velocity of a particle, v bar, is t cube by 3 I cap. T square by 2 j cap plus 3t k cap. Initial position r bar is I plus j plus k. Find acceleration as function of time t, position vector as function of time t. Let's get that. Now it's vector integration. Like I said, idea is the same. Only thing is that I cap, j cap, k cap will be beside. Acceleration is the easiest one, isn't it? How to go from velocity to acceleration? Differentiate, don't integrate. So you should know like what is given and what is being asked. You can't always just blindly integrate every time. Yeah. Get the position vector. That is the most important thing. Acceleration is easy. I know most of you will get that. Get the position vector. I know typing answer might be a little bad, but give it a try. 2 minutes, I'll show you. Then you can verify your answer. Should I show you? Look at the first one. Acceleration is dv by dt. I am directly writing the answer. In case someone didn't get that, please ask me. So t cube is 3t square. 3 will cancel. You'll get t square I cap. T square is 2t. 2t will cancel. That is t j cap, and that is 3k. So you want position vector. So v bar is dr by dt. So dr bar is v dt bar. So when you integrate this, dr bar integral v dt, this will go from r initial to r final. This will go from 0 to t. Let me show it in the next page. So v bar is nothing but t cube by 3 dt I cap. T square by 2 dt j cap. That. This would be r bar, r initial to r final. This would be t power 4 by 12. Limits will go from 0 to t. This is t cube by 6, 0 to t. 3t square by 2, 0 to t. This would be r final minus r initial, but initial is given I plus j plus k. So instead of putting a number, now we'll put a vector. There's no difference. You're getting it in the limits, right? There is nothing like you always have to keep limits. In the limits also you can keep vectors here, because this r initial is nothing but I plus j plus k. This guy would be t power 4 by 12 I cap, t cube by 6 j cap, plus 3t square by 2 k cap. Shift everything that side. T power 4 by 12 plus 1 I cap, t cube by 6 plus 1 j cap plus 3t square by 2 plus 1 k cap. Have a look at this. Vihan, I think you got it. I hope you're getting it. There is technically no difference between integrating a vector and this thing. Only thing, the limits, instead of putting numbers, we'll put limits में integral, we will put vectors in the limits. Do check it out. Anyone not clear with this, not convinced with any particular step, please ask.
So can I go to the previous page?
Previous page, yeah.
Done, sir.
Clear, na? Everyone, all clear with this thing? Any doubts? Ahana, Daksha, clear? Devansh, Nikhil, Vignajit,
So,
how was this?
so what if instead of our initial vectors I cap, j cap, k cap format, if we try putting the magnitude, will that still work?
Arey God, you're integrating a vector.
Yeah.
So your limit should be vectors,
Okay.
right? It's like asking, you have 5 apples, I removed 2 apples from that. So how many mangoes you have? See, you found it weird, na? It's like that. You are integrating a vector, so you have to get a vector. Okay. If you are integrating mod dr bar, now what are you integrating? Magnitude of a vector. Then your limits also will be magnitudes. Are you getting it? Whatever you're integrating, those limits belong to the same category. That way.
Yeah. Okay. Got it.
But that was a good question, actually. You have 5 apples, and if you remove 2 apples, how many mangoes you have? Next thing. Acceleration is sine 2t I cap plus cos 2t j cap. At t is equal to 0, velocity is 0. Find velocity as function of time t. Basically, now we're doing vector integration. These are the kind of questions which you can expect actually. No one actually cares about just integration. Using integration to find areas and volumes, or using integration to find acceleration, velocity, position. These are the most important thing in physics for us. And you can see, right, are we really doing big integrations? The actual integrations are very easy. Let's get this. You guys got trapped. Nikhil, I think you got it. Everyone else, like I expected, you all goofed up. Arya, you got it. Devansh, you goofed up. Devansh, where is your I cap, J cap? God. You also didn't write your I cap, J caps. Vectors, this is a vector. You just can't put the numbers there. Nee, Purvaja. You guys are goofing up the limits part. I'll tell you what you goofed up. Cos 0 is not 0. If you understood what I mean. Cos 0 is not 0. Arya got it. Let's see, I think. Yeah, others, Nikhil, you got it. So acceleration is dv by dt. Don't be sorry, Ray. You guys will keep doing a lot of mistakes. We keep saying sorry, it'll be just too big thing. Learn. That is the whole point, right? I know you guys will get trapped. That is the whole point of the question. Just make sure you don't do the mistake again. So dv bar sine 2t dt I cap cos 2t dt j cap. Integrate on both sides. This will go from 0 to v. This will go from 0 to t. This will go from 0 to t. And I hope you remember the integration. Sine ax plus b dx is minus 1 by a cos ex plus b. I'm not putting that constant. Cos ax plus b dx is plus 1 by a sine ax plus b. There. So this guy would be v 0 to v bar. Sine 2t guy integration is minus 1 by 2 cos 2t I cap. So you have to keep the I cap J cap, huh? Don't forget that. This is half sine 2t 0 to t J cap. So this is v bar. This is a mistake people do generally. Cos 2t. This is cos 0. And unfortunately, that option will be there in the answer what you got. This is sine 0. So send that minus inside. This will be 1 minus cos 2t I cap sine 2t J cap. There. That's your answer. Check it out. You must have goofed up this part only when you keep the limits. Rest of the things, I'm sure you must have got it. Clear, everyone? Next one. Next one. Acceleration is t square I cap plus 1 by t square J cap. What can I do? I can't do anything actually here. Okay. At t is equal to 1, b is equal to 0. Find velocity as function of time t. Straightforward. Now be careful. 0 to v, this should be 1 to t. Don't put always 0 to t and 0 to v. At t1 v is 0, meaning your lower limit of time is 1. This is t cubed by 3. Limits will go from 1 to t. This is minus 1 by t square is minus 1 by t. Limits will go from 1 to t. So v bar would be t cube minus 1 by 3 I cap. This thing would be minus 1 by t minus 1, and minus inside 1 minus 1 by t j cap. Check. Yeah, right, Ahana. You got that right. Easy. I hope everyone is getting the hang of these things now. I can give you simple x, I can simply give you an integral. It doesn't matter. It's always the same. Only thing the ij cap will be beside. just clear with this? Prashank? Clear, na? Adjust your cam a bit. Daksh, clear with this?
Sir, can
Jainil?
you explain the second integration?
वो integral t power minus 2 dt ना रे. So t power minus 2 plus 1 by minus 2 plus 1.
Okay, sir.
Minus 1 by t था वो. ना? Next one. Now, every time they won't ask questions like this also. Let's say we have a resistor. R is equal to 10 ohms. So Q is the charge flowing through the resistor. Where Q ka value is given by T square minus T. Meaning, as time passes, more and more charge will flow. Okay. Now, so this is some of the data. The current I is given by dq by dt, rate of change of charge. So this information is given. The heat produced in the resistor is given by I square R dt. I is the current, R is the resistor, and this is the heat produced formula. This much information is given. Question is find the heat produced in 2 seconds. So there is a certain charge Q which is not constant, it's flowing through a resistor. R is 10 ohms, so Q ka value is given T square minus T. So this is how they'll frame with words. So current is dq by dt, heat produced is I square R dt. I'm sure you studied in school, heat is I square R into time. Power into time basically. So if the current is not constant, you have to integrate. If current is constant, you can directly do I square R into time. So find the heat produced in 2 seconds. So this is how paragraph questions will be framed. They will take something which you know, they will add something which you know, but they look little weird. It works out. Technically, this, I will teach you this later on in current chapter in 12th. So right now I'm giving you this information. Try. You got 2 minutes. Easy one. We have some answers. Nay, just that's not the answer. Nikhil, you got it right. Devansh, you got it right. Vignajit, Ishana, wrong. Yep, you have two right answers. Nikhil and Devansh. Remaining are wrong. We see where it is going wrong. In this question, you have to differentiate, you have to integrate, you have to do both. And who square function, people, it's I square, it is not I. Hope you squared it. Surya, you're pretty close. You messed up something. Right, Vihan? Right, Purvaja, you got it. We have four answers. Nee, Daksha, that is wrong. Anyone else? Nee, Arya, you goofed up. Nee, Ansh, goofed up. Let's see. So first thing, current I is dq by dt. So differentiate. So current is 2t minus 1. So heat produced is integral I square r dt. So I is 2t minus 1 whole square, r is 10 into dt. How many seconds? 2 seconds. So limits will be 0 to 2. You forgot the 10 Surya. Yeah. Then the 10 is constant. Put it outside. Integral, expand this. 4t square minus 4t plus 1 into dt 0 to 2. So 10, I am directly integrating this. This is 4 t cube by 3 minus 4 t square by 2. And this is t. Limits will go from 0 to 2. 0 to 2, 0 to 2. This is 4 into 2 cubes, so that is 8. So that is 32 by 3. This is 8 and this is 2. So that is 32 by 3 minus 6. 3 is 18. That is 14. So 140 by 3 joules. Yep. Please check where you goofed up. Easy? That's what I said. The integration is quite easy. It's just x power nk integration. You just have to be careful with the limits. Anyone not clear with the steps? Anyone who didn't get this, please ask. Clear, no? Next one. So that is, some variations of problems, based on kinematics based problems. And this is like a current based problems. So we'll keep seeing like this more of varieties. So in integration, right, there is one more higher level of integration, right? Now that is more of a max oriented, but in physics, we will encounter, there are 2 to 3 models which keep popping up multiple times. So we'll be seeing those models. And whenever they come in physics, I'll teach you. But it is important that you see them once. In 12th, when they actually teach you the max, all this will look like a joke. For now, it will look like, yeah, a little tough. But so this method, right, is called integration by substitution. We will encounter this in the next class only in kinematics. So sometimes integrations are not so straightforward and they'll get pretty weird. So in maths, you have a set of techniques to handle them, but in physics, there are 3 models especially. Let's say someone gives you an integration like this, integral x dx by root over x square plus a square into x dx. Look at this thing. This thing doesn't look like any common integration that we know, isn't it? So the idea here is we need to find a suitable expression to substitute so that the whole integration gets simplified. Now, how do we know this? Max people have figured it out. They maybe must have done hit and try a lot of things. So let's not get into how we got this, but let's see what to substitute here. So this is what we do. So we put x square plus a square is equal to t square. Now differentiate on both sides. So for this kind of integration, we have to see this, you will realize why. So when you differentiate on the left hand side, it will be 2x dx. A is anyway 0. This will be 2t dt. Now substitute this thing in that integration. So root over x square plus a square becomes t square. X into dx becomes t dt. This integration simply becomes t square dt, which is t cube by 3. But what is t? X square plus a square. So x square plus a square whole power 3 by 2 by 3. Did you see? This complex integration simply became t square dt integration. That's why we call it integration with substitution. You make it more simpler. You bring it to the form which you know. And if you ask me, sir, how do you know we have to do this? A little idea here, think about it. When I took this thing as t square, first of all, it will come out of the root. That is the first advantage. Root is eliminated. Second advantage, this differentiation becomes x dx. So this x dx will get replaced with t dt. So this also will get eliminated. You're getting it? So you can't do this every time. For example, if this is x square dx, then you're gone. You can't do this. You're getting it? So this method works specifically for certain types of cases. You can't use this randomly. But physics, maybe we'll see this thing. Next class, we are going to encounter this thing. So do keep it in mind. So all that you need to know is whenever you see an integration like this, how to do. So remember for now, don't worry too much like what and all. Let's not get into the working of this. Another form of the same thing is dx by x dx by root over x square plus a square. So here just now we saw x dx is t dt, root over x square plus is root t square. So that simply becomes t dt by t, which is integral dt. So the answer is t, but what is t? Root over x square plus a square. So that's the answer of this integration. See, such a complex integration, you can simplify it further and it becomes quite easy to solve. So this method is called integration with substitution. This is one format which you will encounter. Clear? Last time, na, Daksha, you're asking something like this. Secant cube x dx. So this can be written as integral. What is secant x? 1 plus tan square x secant x into dx. So put tan x is equal to t. What is tan ka differential? Remember tan ka differential? What is tan ka differential for what? Tan is sine by cos secant square x, no? So write this thing as root over 1 plus tan square x into secant square x. So put tan x is equal to t. So when a differential will get secant square x, so this will become dt. So basically it is also integration with substitution, but physics may never encounter this, so don't worry. I hope that is what you asked last time, right? Yeah.
Yes, sir.
वो integration by substitution method से करना था वो. This is not the product rule. We have a product rule in integration, but like I'm saying, don't worry about it. We don't need so much. Let Max will teach you. That is a first form. There's a second type of integration we'll encounter. Dx by root over a square minus x square. This also we'll see in kinematics in the next class, not in the next class, later on. But this comes a lot in a chapter called oscillations. So here we substitute x is equal to a sine theta. Differentiate on both sides, we'll get dx is equal to a sine ka differential is cos theta d theta. Substitute. This will become a cos theta d theta. Denominator becomes a square minus a square sine square theta. You end up with a cos theta by a cos theta into d theta, which is integral d theta, which is theta. So from here you can clearly see sine theta is x by a. So theta is sine inverse x by a. So this formula which we have, dx by root over a square minus x square is sine inverse x by a plus constant, because I'm not putting any limits. So this is your second form of integration. Second thing which we'll see quite commonly. So have an idea about these things, and don't worry, like, even if you forgot, every time this comes, I'll show you. And by the time they teach you in Max next year, I think they'll teach you around May, June time, this time. You guys will, right now I'm seeing with your seniors, right? It is a breeze. You'll be so happy that I taught these things. You'll think these are like small puppies. Just imagine cute small puppies. Max में they'll teach you like Godzillas and dinosaurs running around, breathing fire, King Kong's fighting. It's a mess. I hated integration at 12th में Max में. But it's a pretty high weightage topic. Clear? The third form. This comes a lot, huh? Third one comes a lot, but mostly 12th standard mein. Dx by x square plus a square. So here we put x is equal to a tan theta. Differentiate this, so dx is equal to a tan ka differential is secant square theta d theta. Substitute. A is x square theta d theta by a square 1 plus tan square theta. This would be secant square theta d theta by a secant square theta. That cancels out. You end up with integral d theta, which is theta by a. Theta is tan inverse x by a. So dx by x square plus a square is tan inverse x by a plus constant. There, we can show more variations of these kind of things, but I hope you got the idea there. And this won't be the problem actually. The headache would be converting the equation till here would be the biggest headache in physics. Meaning recently there was one question we are doing something similar like this. Look at this thing. So we got an integration like this. K lambda x dx x square plus dx square. So we kept tan alpha x by 2 with dx, we substituted here. So the headache was, converting a problem like this into this would be the headache. The integration is actually the easy part. So don't worry about too much about this integration part. You will get the hang of it. But still, have this much idea, like, when you see something like this, you have to do like this. Clear with the three cases? So do check it out. So these are the things. So with that, we have done with calculus for physics. Right? So if you see in integration, especially the most important ones are the radius and volumes and the relation between the velocity, acceleration, and position vector. And these three models of, integration by substitution. So next class onwards, we'll be starting off with kinematics. So you can say that is officially like the proper physics chapter. Right? You will see more of a physics and Max will still come, but it'll be fun. It's a big chapter. That should take almost 1.5 months, I guess. So kinematics will go. Kinematics is a pretty long chapter. It has a lot of things, 1D, 2D, graphs, this, a lot of stuff. Okay, so with that, we'll wrap up for the day. Right? So when we catch up on Thursday, we'll be starting with a new chapter. So do make sure to revise the whole stuff. Right? You can finish off the booklet, which I gave you. You can finish your classes material, anything. So finish off solving. And exam ka paper, I'll post the results tonight. So you can resolve the paper and we can discuss the paper again on Thursday.